Hi guys. We are still in Unit 2, Notes Packet number 1, and I want you guys to start, let's see where we're at. We are on page 24, okay? And I cannot stress enough to you how very important today's notes are, so I want you to pay very, very close attention. If you don't understand something, stop it and re-listen to it, okay? So again, we are on page 24 of your notes packet, okay? We are talking about the real number system, okay? And that's kind of the world we live in this year, okay? Numbers are categorized based on their characteristics, okay? So we have what we call the real number system. And in that real number system, you can either be a rational number or you can be an irrational number. Okay, we're going to start with what a rational number is. Okay, and there's going to be two characteristics. So we're going to say one. The first one is that it's any number that can be written in, let's say, A over B form. Okay, and what that means is that it can be written as a fraction. Okay, and we have to say where A and B are integers, and we'll get to what integers are in a second, and B does not equal 0, because you can never have 0 in a denominator. Okay, so what I'm basically telling you is that a rational number can be written in the form of a fraction. So we have things like 1/3, okay, and 1/4, and even a number like 12, because 12 can be written in the form of 12 over 1, which is also a fraction, okay? So that is what a rational number is. There's one more definition of a rational number, and we're going to stay in the blue because we're talking about rational numbers. In that other definition, we're going to call it definition 2, is as a decimal. So you can have decimals, okay? Let's write as a decimal. A rational number either terminates in a terminating decimal, means it stops, okay, or it repeats in a pattern. Okay, so that's what a rational number is. Okay, it either can be written as a fraction, or if it's a decimal, it either repeats in a pattern. So something like, let's see, so an example, sorry, my pen didn't work there. If it repeats in a pattern, it would be like if you had 0.3 and it repeats. So it's 0.333333. And why is that? Because that can be written in the form of 1/3, right? Because that equals 1/3. It terminates or stops, so maybe we have something like 0.25. And you know that that's actually 1/4. So basically, it's decimals that can be rewritten as fractions. If it repeats in a pattern, it can be rewritten as a fraction. And if it terminates or stops, it can be written as a fraction. Okay, so that's the first thing I want you guys to know, what a rational number is. Then we get down into an integer, okay? And an integer, we consider, let's say, well, let's call them counting numbers. And their opposites. Okay, so we have things like, let's go down here, right here, and we will say, so we have negative infinity, okay, all the way to -3 and -2 and -1 and 0 and 1 and 2, etc., 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 all the way till we get to infinity, okay? So it's all your counting numbers plus their opposites, negative infinity to infinity, okay? Then we go down to whole numbers, and whole numbers are 0 on up. So 0, 1, 2, 3, ... to infinity, okay? So it does not include negative numbers. And then we have natural numbers, and those are going to be our counting numbers, okay? 1, 2, 3, 4, ... infinity, okay? It does not include 0. The thing I want you to take away from this is that it's kind of like a hierarchy, okay? If you are in, let's go back up, the real number system, you're either in rational number or an irrational number. From there, you get more and more specific, okay? Maybe I'm the number 2, which means I'm a whole number. I'm also an integer because I can be written as 2 over 1. I'm also an integer because an integer includes 2. I'm also a rational number because I can be written as 2 over 1. Okay, but just because I'm a whole number doesn't mean I'm necessarily a counting number. Okay, you may be. Okay, let's go over to irrational numbers. Irrational numbers, there's a couple definitions we're going to talk about here. The first one is that they cannot be written in A over B form using integers. Okay, so for example, pi. That equals 3.14 dot, 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 dot. It goes on forever, okay? That is not rational. That is actually irrational. Okay, another definition would be when we're talking about decimals. So as a decimal, you don't terminate. Means you keep going on and on forever like pi. Or you don't repeat in a pattern. Okay, you don't have those, oopsie, that's an N. And then we could also classify it as any whoopsie, that's supposed to be a 0, any non-perfect square or non-perfect cube. Okay, those are absolutely irrational. Okay, I just want to make sure you guys are really solid on this. So if you can get out a piece of paper or you can just listen for a minute. If we go over, and I'm going to flip over to this page, okay, I just want to talk about the hierarchy again. Okay, so we are either, let's say I want to do black. It's easier to see, I believe. Oh, let's see. Okay, here we go. Sorry about that. So we are either, let's just talk about my hierarchy again. We're in the real number system. We are either rational or we are irrational. I can't spell today, can I? Okay, so let's just pick any number. Let's pick the number 0. Okay, let's pick the number 0. Well, I am in rational category because I can be written is 0 over 1. So I'm rational. Then I go down to my next level. Am I an integer? Okay, am I an integer? Well, we know that integers are from negative infinity all the way up to infinity, so that includes 0. So yes, I am an integer. Okay, next I have whole numbers. Am I a whole number? Well, that's 0 on up to infinity. So yes, I'm a whole number. Now we talk about our natural numbers. Okay, question mark. Natural numbers are 1 on up, right? We don't include 0, so it is not a natural number. So this would be my classification. I'm a real number because we're in the real number system. I'm rational, I'm an integer, and I'm a whole number. The most specific would be a whole. That's my most specific categorization, okay? Okay, let's go back to our notes. I just wanted to give you an example, and let's go on to the next page. Okay, here it says classify numbers into the number system. Classify the following numbers by circling or highlighting all the subsets to which it belongs and write the best or most specific description in the last column. Okay, 144. So I just want to make sure we're clear. When we're talking about irrational or rational, you are one or the other. Okay, you're either or. You're not both. Either or. You're not both. So here we have a rational number. Okay, so we're going to circle that. We are always going to be talking about numbers in the real number system, so we're going to be real. That's the first one, okay? So we are not irrational. Now let's talk about it. An integer, well, that is from negative infinity to infinity, so we're an integer. 0 on up, well, we're a whole number, and we are a natural number. And my most specific is going to be natural, okay? Next, negative 12 over 1. Well, we're real. We can be written, let's see, we can be written in the form of negative 12 over 1. We can be a fraction. So we are rational, not irrational. Are we an integer? Well, that's negative infinity to infinity, so a negative number would count as an integer. We are not a whole number because we are not 0 on up. We're less than 0, and we're definitely not natural. So my most specific is going to be an integer, okay? I hope you're starting to get the hang of this. Square root of 625. Well, 625 is a perfect square, as I recall. That's going to be 25. So I have a nice number 25. I'm always going to be in the real number system. I'm either rational or irrational. Well, that's rational, okay, because I'm not a decimal. I can be written in the form 25 over 1. An integer, negative infinity to infinity. Yep, I'm good there. A whole number is 0 on up. I'm good. And a natural number, 1 on up. Yep, and then my most specific is a natural, okay? 1/3. Well, this is an interesting one. How can it can be written as a fraction. It's a decimal that terminates, or I'm sorry, that repeats 1/3. It repeats in a pattern. So I'm still real. I'm still not irrational because I can be written in fraction form and I'm a decimal that repeats in a pattern. So I'm rational, okay? But that is where I stop because integers are negative infinity to infinity. They're like counting numbers, right? They don't include our little fractions here. So we're in none of those. So my most specific is going to be a rational number, okay? Let's see, the cube root of 729, perfect cube. We got a 9 there, so we're always real. That one's going to be rational. Let's think, are we in an integer? Negative infinity to infinity, yes. Are we whole, 0 on up? Yep. Are we natural, 1 on up? We are. And my most specific, oopsie, is natural, okay? 0.74. That is a decimal. That's supposed to be a T. It doesn't look much like one. That terminates, okay? Which means I am a rational number still, okay? I am not going to be an integer, though. I'm not one of those counting numbers or its opposite. I'm not 0 on up, and I'm not 1 on up. So my most specific is, once again, a rational number, okay? Now we've got the square root of 2. 2 is not a perfect square. If I were to put that in my calculator, I'd get a decimal that keeps going on forever. So I am actually an irrational number, and that is where I stop. We do not break irrational numbers down any further. Okay, let's see. 0.1212221. No, that's just going to keep going on forever. So we are going to say real, and we are going to say irrational. Okay. And negative square root of 25 is -5. We're real, we're rational, we're an integer, but we can't be whole because we're not 0 on up. We're actually a negative number, and we're not a natural. So my most specific is an integer. Okay, I hope you're starting to get the hang of this. We're going to do lots more practice in the next couple days. Going on to key ideas. The square root, let's see, of any whole number that is not a perfect square, cross that off, is irrational, okay? So the square root of any whole number that is not a perfect square is going to be irrational. So like the square root of 51, let's say. Okay, the cube root of any integer that is not a perfect cube, okay, is also going to be, let's cross that off, irrational. Okay, because it's going to give me a decimal that keeps going on forever. So let's say the cube root of 12. That is not a perfect cube. It goes on forever. Okay, and then down here we're saying that the decimal form of any irrational number neither terminates or stops, so it doesn't terminate, nor repeats in pattern. Okay, let's just cross that out. For rational numbers, the decimal form either terminates or repeats in a pattern. Okay, so we can have things like 3/5, that's going to be 0.6, or we can have 2/3, which is what, 0.6 repeating. Those would both be rational numbers. Okay, moving right along, we are going to cover one more topic. Okay, so we are on page, let's see where we're at, 26, okay? I'm not going to lie, this is super tricky, so you have to follow along. When we get square roots that are not perfect squares, we have to be able to approximate them without using a calculator, okay? So in 2a, it says estimate the square root of 37 to the nearest integer and to the nearest tenth. Complete the table, blah, blah, blah. Okay, so we are finding the nearest, find the nearest perfect square. Okay, what that means is if I have the square root of 37, I'm going to use my yellow sheet, and I'm going to see what perfect squares are on either side. So the next one next to it on the left is the square root of 36, and to the right it's going to be the square root of 49. 37 falls in between there. Okay, and if I'm looking at the square root of the nearest number, so this one is going to be 6, that's going to be 7. Okay, I want to see which one it's closer to. Well, this has a distance of 1 unit. Okay, 36 to 37 is 1. The distance from 37 to 49 is what? 12 units. So I am much closer to the number 6. Okay, so that's where I'm closer to. I'm closer to 6. Now, this is where it gets super tricky, and you kind of have to do some memorization. Okay, it says calculate the difference of your given number and the nearest perfect square. Okay, we did that. Now, it says, remember we took 37 minus 36 to get 1. There is 1 unit between the nearest perfect square. Okay, now fraction numerator. Okay, so we take what we're starting with, 6. We're closest to that. We know if we look over here, 37, the square root of 37 is a little bit bigger. So we want to add a little bit more to 6. So I'm going to add. If you want to think of it this way, it's add this difference if the nearest perfect square is less than the number you were trying to estimate, okay? But I just like to think of it this way. If I'm to the left, then I want to get a little bigger. If I'm to the right, I want to get a little smaller. So I know that my perfect square I'm closest to is 6. And now, that difference, okay, that difference that you found up here, difference, I can't spell, goes in the numerator. It's a difference of 1. Okay, this right here, sorry, I'm jumping ahead. Fraction in the denominator, always 2. Okay, it's always going to be 2. You're going to take 2 times the square root of the nearest perfect square. And we said the perfect square we chose was 6, so we're going to put it down there. Okay, and we get 6 plus 1 over 12. Okay, so 6.112. I don't want to use your calculator, so let's just say that 1/12 is close to 1/10, and we know that equals 0.1. So let's make it a 6.1. You could also actually go 1 divided by 12, right? And you could get 0. Oh, sorry, it goes in 0 times. Bring down the 10. Bring down another 0, and that's going to be about 8. 0.08, which is 0.1. And you get 6.1. Then we just graph it on the line. I'm going to do the square root of 36 down here. And then we've got 6.1, 6.2, 6.3, 6.4, etc. Okay, and we know the square root of 37 is right here. So that's where we graph it, okay? So my answer is my closest integer. Well, we just said we're the closest to the square root of 6, or 36, which is, 6. And my 10th is going to be approximately 6.1. I know that's confusing. I do not expect you to get it on the first try, but the more you practice, the more you will be able to get these down. Okay, let's go to the next page. Let's do one more. We have estimate the square root of 78 to the nearest integer and to the nearest tenth. Okay, remember, first we're going to find the nearest perfect square. Okay, so let's think about this. We have 78. To the left, if I look at my sheet, it's going to be square root of 64. Okay, that's the closest to 78. On the right, the next biggest is going to be the square root of 81. The square root of 64 is 8. The square root of 81 is 9. Let's see how close I am. 64 to 78 is 14 units. 78 to 81 is 3 units. So I am much closer to the square root of 9, okay? So I'm going to go ahead and I'm going to put 9 down here because I know that that's what I'm closest to. Okay, complete the difference of, let's say, the given number and the nearest perfect square. Well, we said that it's 3, right? We know it's 81 minus 78 equals 3. Okay, now there is a typo. Let's just write this now so you guys catch it. I think as I reread this, that this is a typo. You're going to add the difference if the square root, let's see, these are opposite. This should be less and this should be greater. Okay, but I don't even want you to worry about that so much because I think if we think of this logically, we're going to get it. Okay, so we're starting with 9. We said that's the closest square root. Okay, let's go up here. If I'm here and I'm at 9, right here, I want to get to 78. I want to get a little bit smaller. So I need to subtract a little bit from 9 to get a little bit smaller to get closer to 78. Okay, and now I just do the same process I've been doing. I put that difference on top. Okay, we're going to do the difference on top, which is 3, over always 2 times the square root of the nearest perfect square. So we put that there. And I get 9 minus 3 over 18, which is 9 minus 1/6. Okay, and you can do the math. That's 8 and 5/6. Okay, and then I go down and I just divide 5 divided by 6. So we're going to get 5 divided by 6. Oh, what is that? We got an 8. 0.83 keeps on going, so we're going to do 0.8. So my answer is 8.8. Okay, so my nearest integer is approximately 9, and my nearest 10th place is 8.8. Okay, and then if we wanted to graph it, you can graph it on your number line. Okay, let's see where we're at here. I'm going to let you guys use these 2 examples to try to figure out the rest of them.